The Physics of Star Trek by Lawrence Krauss. Copyright 1995 by Basic Books, a division of HarperCollins Publishers, Incorporated. This recording of the full-length reading of The Physics of Star Trek was published by arrangement with HarperCollins Publishers, Incorporated. All rights reserved, and was produced in 1996 by Books on Tape, Incorporated, which holds the copyright thereto. Neither this recording nor any part thereof may be reproduced or used for any purpose without prior written authority from Books on Tape, Incorporated. This book is read by Larry A. Mckeever. The Physics of Star Trek by Lawrence Krauss. This book consists of 10 chapters and an epilogue and is 179 pages long. The following material appears on the dust jacket of the book. If you enjoy watching Star Trek, you're in good company. Some of the most distinguished physicists in the world, from Kip Thorne to Steven Weinberg and Sheldon Glashow, tune in, and a popular pastime at professional physics meetings and over email is a discussion of the science in the series. Now you can join the fun. How does the Star Trek universe stack up against the real universe? Find out what the series creators got right and wrong about science in this fascinating guide by a renowned theoretical physicist. Anyone who has ever wondered, could this really happen, will gain useful insights into the Star Trek universe, and, incidentally, the real world of physics, in this charming and accessible guide. Lawrence M. Krauss boldly goes where Star Trek has gone, and beyond. He uses the Star Trek future as a launching pad to discuss the forefront of modern physics today. From Newton to Hawking, from Einstein to Feynman, from Kirk to Picard, Krauss leads you on a voyage to the world of physics as we now know it, and as it might one day be. With a foreword by the most renowned Trekker of all, and one-time next-generation bit player, Stephen Hawking, and featuring a section on the top 10 physics bloopers and blunders in Star Trek as selected by Nobel Prize-winning physicists and other dedicated Trekkers. This is a volume that will add a whole new dimension to your enjoyment of the series, and to your appreciation of the universe we live in. Lawrence M. Krauss is Ambrose Swayze Professor of Physics and Professor of Astronomy and Chairman of the Department of Physics at Case Western Reserve University. He is also the author of 2 acclaimed books, Fear of Physics, A Guide for the Perplexed, and The Fifth Essence, The Search for Dark Matter in the Universe, and over 120 scientific articles. He is the recipient of several international awards for his work, including the Presidential Investigator Award given by President Reagan in 1986. He lectures extensively to both lay and professional audiences, and frequently appears on radio and television. This book was not prepared, approved, licensed, or endorsed by any entity involved in creating or producing the Star Trek television series or films. What warps when you're traveling at warp speed? What's the difference between the holodeck and a hologram? What happens when you get beamed up? What is the difference between a wormhole and a black hole? What is antimatter, and why does the Enterprise need it? Are time loops really possible? And can I kill my grandmother before I am born? Discover the answer to these and many other fascinating questions as a renowned physicist and dedicated Trekker explores the physics of Star Trek. Today's science fiction is often tomorrow's science fact. The physics that underlies Star Trek is surely worth investigating. To confine our attention to terrestrial matters would be to limit the human spirit. From the foreword by Stephen Hawking. The dedication. To my family. But I cannot change the laws of physics, Captain. Scotty to Kirk, innumerable times. Forward, Stephen Hawking. I was very pleased that Data decided to call Newton, Einstein, and me for a game of poker aboard the Enterprise. Here was my chance to turn the tables on the two great men of gravity, particularly Einstein, who didn't believe in chance or in God playing dice. Unfortunately, I never collected my winnings because the game had to be abandoned on account of a red alert. I contacted Paramount Studios afterward to cash in my chips, but they didn't know the exchange rate. Science fiction like Star Trek is not only good fun, but it also serves a serious purpose, that of expanding the human imagination. We may not yet be able to boldly go where no man or woman has gone before, but at least we can do it in the mind. We can explore how the human spirit might respond to future developments in science, and we can speculate on what those developments might be. There is a two-way trade between science fiction and science. Science fiction suggests ideas that scientists incorporate into their theories. But sometimes science turns up notions that are stranger than any science fiction. Black holes are an example, greatly assisted by the inspired name that the physicist John Archibald Wheeler gave them. Had they continued with their original names of frozen stars or gravitationally completely collapsed objects, there wouldn't have been half so much written about them. One thing that Star Trek and other science fiction have focused attention on is travel faster than light. Indeed, it is absolutely essential to Star Trek's storyline. If the Enterprise were restricted to flying just under the speed of light, it might seem to the crew that the round trip to the center of the galaxy took only a few years. But 80,000 years would have elapsed on Earth before the spaceship's return. So much for going back to see your family. Fortunately, Einstein's general theory of relativity allows the possibility for a way around this difficulty. One might be able to warp space-time and create a shortcut between the places one wanted to visit. Although there are problems of negative energy, it seems that such warping might be within our capabilities in the future. There has not been much serious scientific research along these lines, however, partly, I think, because it sounds too much like science fiction. One of the consequences of rapid interstellar travel would be that one could also travel back in time. Imagine the outcry about the waste of taxpayers' money if it were known that the National Science Foundation were supporting research on time travel. For this reason, scientists working in this field have to disguise their real interest by using technical terms like closed time-like curves that are code for time travel. Nevertheless, today's science fiction is often tomorrow's science fact. The physics that underlies Star Trek is surely worth investigating. To confine our attention to terrestrial matters would be to limit the human spirit. Preface. Why the physics of Star Trek? Gene Roddenberry's creation is, after all, science fiction, not science fact. Many of the technical wonders in the series therefore inevitably rest on notions that may be ill-defined, or otherwise at odds with our current understanding of the universe. I did not want to write a book that ended up merely outlining where the Star Trek writers went wrong. Yet I found that I could not get the idea of this book out of my head. I confess that it was really the transporter that seduced me. Thinking about the challenges that would have to be faced in devising such a fictional technology forces one to ponder topics ranging from computers and the information superhighway to particle physics, quantum mechanics, nuclear energy, telescope building, biological complexity, and even the possible existence of the human soul.
Sample complete. Ready to continue?